All right, first, thanks for Mara for providing this opportunity to present this work. I'll just start with a few just quick definitions that I'll be running through with through the presentation. So VOCs, or volatile organic compounds, non-methane hydrocarbons, NMHCs, are an operationally defined term that are here interchangeable with VOCs. And I'll be focusing on BTEC species. So these are benzene, toluene, ethylbenzene, and all the xylenes, as shown here. So why exactly are we measuring VOCs in general? VOCs are defined as toxic compounds as given in the Canadian Environmental Protection Act of 1999. VOCs can affect your health in any number of ways, including direct effects such as benzene, which is a carcinogen, and also indirect effects in their roles in that they play in secondary chemistry in forming secondary particulate matter, for example. If we want to measure VOCs, it is important to understand the sources of VOCs in the area in general. So VOCs can come from a number of anthropogenic sources as well as natural sources, but here I have some trend report, the latest trend report from Environment Canada as of 2014, showing that in general across the country, VOC emissions are on the decrease. And one of the largest contributions to VOC emissions, anthropogenic emissions, are the industries within oil and gas. So as I mentioned, there are natural sources as well. And focusing now more specifically on BTEC species, natural sources of benzene and toluene, for example, include wildfires and also natural erosion of deposits within the ground. Anthropogenic BTEC emissions do also include oil and gas industries, as was the case for general VOCs. And in the regional, Wood Buffalo Regional Municipality, we can narrow down a number of these BTEC emitters and look at, according to the NPRI, 96% of those BTEC emissions are coming from 4 different facilities, generally located around Fort McKay area. And these facilities are shown here on this map as the red triangles. Fort McKay is indicated with the the orange circle number 1 there. Given this type of information, we can ask a couple of key scientific questions for this project. So first, what are the general concentrations of BTECs given its proximity to these BTEC sources? And second, what can we learn about BTECs in terms of their behaviors and their sources within the oil sands region when making comparisons between BTECs concentrations and other air quality parameters and meteorological parameters? Quick site description on where we were measuring. So this, we have a sampling monitor based out of Fort McKay Station, so it's AMS-1, Fort McKay Bertha Ganter Station. This is in conjunction with WBIA. It is their station, and we are very thankful for their continued cooperation in using that station. Fort McKay is within approximately 10 kilometers of some major oil sands developments. And we have installed this monitor in the fall of 2011, and it's currently ongoing. It is an ongoing project within Jocelyn. But I'm only going to be talking about 2014 data, so the full year 2014. The methods that we've used to measure BTECs here in Fort McKay, it's a semi-continuous method, gas chromatograph. And we're sampling near real-time analysis with it's approximately 15-minute sampling frequency. We're using hourly average data for the final analysis. The instrument itself is validated with daily spans and zeros to ensure proper operation. And the instrument itself operates with approximately a 5% reproducibility at the lowest reportable limit. So here I've given a table of the lowest reportable limits that we are using for each of these of the BTEC species. They are dependent on the species, and you can think of it as a conservative method to rather than the detection limit, say. So this is, I'll just explain this a little bit in more detail here. Here we can see a gas chromatograph from the instrument itself and the species that we're interested in. At very low concentrations of these compounds, we see you see some amount of interference with other VOCs within the air at the time, and it's not trivial to integrate those peaks to estimate or to measure a final concentration of each of those compounds. So therefore, we use the lowest reportable limit here in this case. However, this presents us with a problem in that a significant amount of our data is below this lowest reportable limit. And rather than just throwing it out, we still want to use it. A low measurement is a measurement nonetheless. And so in order to deal with this, the data below the lowest reportable limit is treated with the robust regression order statistics, simply to estimate the summary stats for the data set, which are shown here. So for each of these species, you can see some of the summary stats. So I want to focus your attention first on the valid number of data for each species. So here we can see out of a total of 7,400 data points, we're getting a very slim fraction of those are actually above that lowest reportable limit. In the case of MP xylenes, for example, it's only at about 4% of the data is above that limit. However, we can still estimate the median and the mean shown here. So they are generally low values. I've given some comparable comparisons to ambient air quality objectives out of Alberta for each of the compounds where it's applicable. And there were no exceedances of these objectives over 2014. Just a quick pictorial view of how the data looked. Again, it was generally low concentrations over the course of the year. And again, benzene hourly AQO is plotted there on the plot. And we can see that there were no objectives on that. There are no exceedances on that objective. Sorry. I'll just focus now on the main events, so the high concentration events in that data set, which were here in August 2014. So looking more closely at this time set, we can see that I plotted here a comparison between PM2.5 and non-methane hydrocarbon, both of which are obtained from the same station by Wabia. And I've plotted the sum of each BTEC species as the red points. The scales and the appropriate scales are on either side. So the first event on August 5th, here we can see a very large spike in PM2.5 concentration associated with our BTEX event. And if we can look more closely at the actual speciation of that BTEX, you can see that it is predominantly benzene and toluene, with only minor amounts of ethylbenzene and xylenes. This is consistent with a forest fire event out of Northwest Territories and Saskatchewan at the time. And I'll use further evidence in the next slide to show you that. The second event, however, we can see that it was a much more narrow event. It only happened in one morning of that day. And we can see the speciation of BTEX here again was predominantly actually toluene and ethylbenzene, MP xylenes, and O-xylene. Very little benzene in this case. So here we can say that it's, given those ratios, that it's more likely to be an anthropogenic event. The forest fire event we can see here on August 5th, the fires given in as the red points on this satellite image. And you can see clearly that the smoke is impacting the oil sands region and Fort McKay in general. So just further confirmation that was a forest fire-driven event. We have here now the second event, the anthropogenic event, and also I've plotted now here the solar radiation corresponding at the station, also measured by Wabia. And here it's the thing I want to point out to here is that this VOC event very likely initiated a secondary PM process in the atmosphere. So as the winds were fairly low that morning, VOCs and BTEX in particular spiked, and we could see as the sunshine picked up over the course of the morning, we see a fairly substantial spike in PM2.5 concentration. So again, it's just to highlight the possibilities of VOCs in the atmosphere. Stepping back a little bit now to the general full data set. I can do some data analysis, or directional analysis on this data. Here, just a quick overview of what I'm plotting. Each of the four source facilities, a straight line direction to them are given as the blue points on the outside of these circles. The gray bars extending out from the centers are the number of data that fell below the lowest reportable limit, and the green bars indicate the number of data that fell above the lowest reportable limit for each 10-degree wind segment. The red line around each circle is the 95th percentile for each 95th percentile concentration for each 10 degrees for each species. And here we can see that for the general idea is that most of these species are originating from the south, with the exception of benzene, which has a little bit of a north and an east component to it. Some caution has to be taken in interpreting such plots, given the landscape in the area. So it is a river valley, and we are sampling Fort McKay is within the river valley. And any number of pollutants can filter down into that river valley and blow up south, from the south. And so we have to take a little bit of caution in interpreting these. And finally, just a few correlations to open up the possibilities of actually sort of fingerprinting different sources with what we can do with this data. So here you can see that the xylenes and ethylbenzene have fairly high correlation with each other. And again, remember that these are predominantly anthropogenic compounds. There's fairly minimal natural sources for these. Whereas on the other hand, benzene does have this natural source of wildfires. And we can see that in the lower correlation factors between the benzene and the other remainder of BTECs. Toluene has both anthropogenic and natural, and so we see sort of a median in between there. Okay, so some conclusions. So based on the first two scientific questions we have, the concentrations were fairly low for 2014, with only a few higher concentration events. And we do have some directional and event analyses that are proving to be useful. However, it'll be more useful with longer term data to show more conclusively what that can bring. Fort McKay, for future directions, we do continue monitoring at Fort McKay. So we are still within the scope of JOSM at that station. We are hoping to expand the capability of the instrument to include several more VOCs of interest. And also, we're hoping to do future comparisons to another instrument operated with Environment Canada at the Oski-Oten station in Fort McKay. And with that, I'll make my acknowledgements, especially to WBIA for their cooperation throughout the process. And I'll take any questions.
Minutes for a minute or two for questions if we have any. Yep. Two over here.
Thanks for your presentation, very interesting. I didn't quite get the benzene, toluene, and other compounds concentration, but I remember the benzene level was fairly low, and the correlation with other species are also low. I wonder, is it because they are from different sources, or you don't have enough higher concentration to correlate? Is the statistical power is not there?
No, I think in this case, the data shows that it's more likely to be a variety of sources that's leading to that, rather than a data limitation.
Carolyn Campbell, Alberta Wilderness Association. Forgive me if I missed it. With the one anthropogenic event or likely anthropogenic event in August 2014, I was left wondering, was that an oil sands facility? Was it another facility? Did it correspond to a notification of the regulator? Or can you, and is there any human or ecological concerns around that. Could you fill that in a bit more?
Yeah, it's hard to say at this point. It is fairly preliminary analysis. I do know that the winds were very low that morning, so it's hard to point to any one given source. But it's definitely something that we will be looking into for sure.
Hi, great presentation. Not to play devil's advocate again, but I'm just wondering, when I look at your statistical methods, how come we're not using published stats guidance on how to deal with data sets with non-detects or below detection limits? Like you specifically referred to a paper, I can't remember which one, which we wouldn't know to necessarily use if I'm regulating and see data come in. So just if you could speak to that a little bit, or if that's kind of your go-to document, if that's published somewhere. And the other question I had was, you mentioned kind of a biomarker compound retine, was it, that you use for forest fires?
No, that was Jane's talk, I know.
Oh, sorry. Okay, then
I can try to answer that though, maybe.
Oh, well, I thought it was, so I was
No.
like, why didn't we look for that here to show that that was from natural sources?
No, this
Okay.
is not capable of measuring those. But yeah, in terms of your first question in how to handle non-detect data, I'd certainly agree that there should be a further documentation on exactly how to handle these, and I think one of the primary places to look for this is in the air monitoring directive, and it's not necessarily there. And in most cases, a lot of the instruments do measure above the detection limit. It's not a huge problem, but because of the number of data that fell below the reportable limit in this case, it really was something we had to put a significant amount of thought into.
I like that it's printing, that's good, great.
Yeah, so that's exactly what I'm getting at. Lots of times we see data sets that are far below with error. So getting knowledge like that out there would be really useful, I think.
Yeah,
to
and a lot of
everybody.
times it's up to the scientist doing the analysis. Like if you were to look at this data set on your own, you can see all the data below the reportable limit and use it as you wish. But in this case, I chose to use this method.
Yeah, that's kind of what I'm getting at. So should it be up to the individual researcher and scientist? Like, aren't we talking about why large-scale monitoring programs here and how to properly look at data? Sorry, not to pick at you, but that's the conversation I'm trying to have.
I think that there's certainly a benefit into having a broader direction in how to handle that, for sure.
Yeah.
But it isn't there. And so it is left up to the individual researchers in this case. But that is also useful too, because it may be better case by case to use one method over another.
Thanks.
Great, thank you.